Hello, and welcome to JavaScript Marathon, a week full of free online courses and some of the leading web development technologies and concepts. I'm excited to introduce Tim Winfred. Tim will be presenting on design patterns in JavaScript and how they can clean up your code. Welcome to JavaScript Marathon, Tim.
Thanks for having me. I'm excited to be here.
Yeah, you can find Tim on Twitter at Contemporary. Pretty clever. I like that.
Yeah, I got to get those dad jokes in.
A special thanks to this week's sponsor, This.Labs, offering personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. If you find keeping up with constantly evolving technologies a struggle and want to bring your team up to speed on one of the latest technologies, you can contact us today at hi@this.co to set up your complimentary needs assessment. And This.Labs is hiring. If you are a senior software engineer or an engineering manager, we would love to hear from you. Send us your resume at jobs@this.co. And we have a ton of events happening next month, as you can see here on the screen. We have State of GraphQL, Vue Contributor Days, State of Angular, our Women in Tech monthly mentoring session, and Modern Web's State of Microservices. And next week, or actually later tomorrow, wow, it's coming up quick. Angular World Tour is continuing in Seattle. Next week, we will be in Athens, and back in October in Memphis. You can find out if we're coming to your town at angularworldtour.com. And we are excited to announce the kickoff of React World Tour at the start of August in Austin. Check it out at reactworldtour.com to see if we're coming to you or to request us to come to your city. We'd love to connect with your local meetups. You can keep track of all of our events on Twitter at this.media. And we'll be back in November with another week of JavaScript Marathon. It'll actually be our final one for the year. Right now we have Mike Ryan with NGRX Training, David Korshid with XState, and Anthony Fu with Byte Training, with more still in the works to get lined up for that week. So you're not going to want to miss it. Follow along and check it out at javascriptmarathon.com. All right, that said, I'm ready to hand the mic over to you, Tim. How are you feeling about it?
Let's do it.
All right.
Let's go. It's early. I never am up this early coding, so hopefully I don't fumble too much. But if I do, feel free to correct me in the comments. Let me know, I did something wrong. Anyways, it's the first day of fall. Happy fall.
Happy fall.
Yeah.
Enjoy.
Thank you. All right, everybody. Thank you for joining me today. As Tara mentioned, I'm going to be presenting 6 awesome design patterns in JavaScript and how they can clean up your code. There's more than 6, but I am choosing to present some of my favorite. I will discuss some more of them beyond that. But before I get into that, I wanted to throw out this little JavaScript and food joke just for Tracy Lee. If you're watching, this one's for you. I'll let it sit on the screen, sink in for a minute. So is non or is not a number in JavaScript, right? Leavened, oven baked bread. If you console log that, it would be true. I found that, and Tracy loves code and food, so that one's for you. I was asked to do this today after I had a slight viral post on blog post on dev.to on the same topic. Feel free to check out the full blog post at dev.to/twinfred. And that's sort of what I'm going to be presenting today as well. So if you want to follow along, you can check that out. So let's jump right into it without further ado. So the first question, if you're unfamiliar with it, is what is a design pattern? So this is a block of text. So I'm going to kind of just read the bolded out parts to you. But a design pattern in software development is a general reusable solution to a commonly occurring problem. It's a description or a template for how to solve a problem that can be used in many different situations. So it's not quite a like copy and paste where, as you know, as a developer, if you go to Stack Overflow, for example, a lot of times you'll just copy and paste solutions. That's what we get paid for, right? In this case, it's a template that allows you to reuse it and repurpose it in a way that makes sense for whatever project you're working on. And it is also sort of a formalized best practice. It is a little controversial because some developers tend to think they make your code a little bit more complex or complicated, but it's a great way of, you might have even recognized several design patterns in your code if you worked in code bases at companies before. And that's part of the whole reason for this. I was asked by a developer a while back if what design patterns I used in my job, and I actually couldn't answer him. I was unaware of the things that I was working on were actually design patterns. So whenever I started writing that blog post, it took me about a week. I dug into all of them individually, really studied them, and I recognized, like, wow, a lot of these are actually things that I've used or I've worked in code bases, and just didn't know that that name or that template for my code was a design pattern. So in JavaScript, there are 3 types of design patterns. There's actually a 4th one called the concurrency design pattern. That's for multi-threaded languages, which, if you know JavaScript, is not. That's why it's not available. Those design patterns aren't used in JavaScript. So the 3 in JavaScript are creational design patterns, which some of these are a little convoluted definitions or wordy, so I'll try to simplify them. And feel free to drop any questions in the comment section as I'm going if the explanations don't make sense. Hopefully, as we get into the code, they will. Anyways, creational design patterns are, as the name suggests, situation-specific patterns that reduce complexity by controlling the object creation. I'm going to be going over 2 awesome, my favorite creational design patterns in a bit. We also have structural design patterns, which is where you realize the relationship among entities to simplify the design of your code. And then lastly is behavioral design patterns, where you identify common communication patterns to increase flexibility in that communication. All right, to kick things off, these are the 4 creational design patterns. The one with the single star, the factory one, is the one I'm going to be going over first. And then the Singleton strict is the one that I will be going over later. I have 6 set aside. I'm going to try to keep this presentation to an hour to be respectful of everyone's time. So I'll try to get through as many as possible. In structural design, these are the 6. Now, there are more in these design patterns as well, beyond the ones that I'm sharing with you today. But not all of them are necessary in JavaScript. Some of them JavaScript has native features, for example, that don't require some of the design patterns. All right. Before I kick things off, if you have any questions about anything I presented so far, about what a design pattern is, feel free, drop it in the comment section. But I'm going to go ahead and jump on over into Code Sandbox to discuss the factory design pattern. I've got my Code Sandbox set up for React at the moment. It comes into play for one of these a bit later because I will be using the Axios library. But if you have any questions about that, again, feel free to let me know. OK, so for the factory pattern, a creational design pattern, we are going to be building an employee factory. So it's sort of separated into a couple different parts. So the first is we're going to create the employee factory first. And then in addition to that, we're going to be creating the employee types. These will be objects. I'm going to be doing functional-based objects. So you can also do class-based objects if that is your preference. And then at the end, we're going to go ahead and create the employees using the factory. So as the name suggests, a factory, if you think about like a garment factory might create certain types of clothes, and they're limited to what they can create because maybe they only have those patterns available. So maybe the factory creates shirts and pants and socks. So those are their three. And if you try to request leggings or a hat, that garment factory can't create that without setting up a new method for that. So that's what we're going to do. Let's go ahead and first, as I said, set up the employee factory. Sorry, you might see some console errors as I go because it's refreshing in real time. All right, so the first thing we're going to do is set up a method called create employee type. And then we're going to pass in that type into it. So this is where we just say like, okay, we create a switch statement, and then we pass in what we can create. So we pass that type into there as the switch. And then we're going to go ahead and give that 3 different cases. Let's say it's for this.labs. And they need, what would she say, senior designers or developers, excuse me. Senior developer. So we're going to go ahead and return a new senior developer. And then break. Otherwise, she said that they need developer managers, I believe. Okay, so, and that will return a new developer manager. So we haven't created those objects yet, but we will in just a second right down here. Oh, got to break that as well. I'm going to make the developer manager the default as well, just in case this yells at me what is going on. This dot create employee type. Oh, I forgot to turn that into a function. Okay, there we go. So there we go. That's literally all that our factory is. As you can see, it controls all of the different types that we can create. Let me just check. Is it possible to receive or download the presentation? Yes, I will make sure that's possible. I'll also post it on my Twitter afterwards. You can also check on YouTube as well. Sorry. Okay, so back to here. So we can, if we wanted at a later point, we can go in and again, going back to the example of the garment factory, if we wanted to add those leggings or hats, we could also add, I don't know, an architect, for example, here, a junior developer, and then allow the employee factory to create that as well. All right, so then next we're going to go ahead and create our senior developer object. Here we go. So this is going to be a function. And then the senior developer, They're going to have a name. So let's go ahead and pass in that name here. And then so name will equal name. And then just to separate it from the developer manager a bit, let's give it a method. Let's say this dot write code is equal to a function. And we're just going to console log writing code. It's probably not going to like this method. Okay. There we go. And then that's just so you can distinguish the difference between the two. Next, we're going to create a developer manager. And that, again, is a functional object. We're going to give them a name as well. And they're going to manage devs is their function. And then that will just console log managing devs. Actually, let's do this dot name plus is, just so we can see the difference between multiple devs. Plus, there we go. Okay, gotta throw in those. Gotta keep my code as clean as possible. Awesome. So that's actually all there is to the factory. You have, oh, I forgot what error name. Oh, it's a protected type. I'm just gonna say F name then. It's their first name. And pass that in there. That's what it is. Didn't pass it in. Okay. Awesome. So oh, that was the employee types. Put that above my object. And then now we're going to go ahead and create the employees using the factory. Let me check for questions. Okay. Create the employees using the factory. So we're going to go ahead and set up our factory first. So const factory is equal to new employee factory, just like that. Hold on, something's up because I'm passing in the name. Oh, right. The name doesn't go into the employee factory. It just goes into here. Not the employee factory. I knew there was something up with that. Okay. So const employee factory, that doesn't take any parameters. And then we're going to go ahead and set up another const and call it employees, and that will be an array. So then what we're going to do is we're going to push new objects into that employees array. So employees.push. And then we're going to create a new object, so using the factory. So factory.create employee type, and we're going to create a, what did we have? Senior developer, and we pass in a name as well, right? So we have type and name on the create employee method. So senior developer, and this developer's name will be Tracy. And then, here, let me widen this a bit. And then we're going to do that again. And we're going to use that factory to create it. And we're going to do a create employee type. And you can see right there we have a developer manager type. And then we're going to make that Tara. All right, so we have that. And then let's just go ahead and do two more. I'm going to copy it for speed. And we're going to have I like this T alliteration. What's another T name? Tanya. All right, so Tracy, Tara, Tim, and Tanya. And then let's just check, make sure everything is working out right. And console log our employees. So here we go. In the console here, you can see we have an array of 4 different objects. And in order that we created it is a senior developer, a developer manager, a senior developer again, and another developer manager. And if we pop that open, you can see the information there. And then if I just come to this console, or actually, let's say employees at 0, and that's a developer. So they are going to write code. So let's just make sure that is working, and that should console log Tracy is writing code. A little bit off with the spacing, but there we go. Tracy is writing code. Awesome. So there you go. We have a factory that is creating employees by their type. I might even put that keyword by in there just to make it a little more obvious. And if I was going to clean this up, I might move this into a separate object, and just so we didn't have to manually type that out and update it in a variety of locations. Awesome. So that's the factory design pattern. Feel free to drop comments. I am checking those out live. Next up, I'm going to go ahead and go into the structural design pattern. So this is where it's, the decorator design pattern, which is a structural design pattern. And that, just like it sounds, is where you're just decorating objects. So the definition here, attach additional responsibilities to an object dynamically, keeping the interface the same. So that superclass is the same. And then you're just decorating each of the individual objects that come out of it. And it allows you to extend the functionality. All right, so I'm going to come here. I'll provide all of this code as well on my GitHub afterwards. It's the same as my, let me comment out that log so we don't see that over and over here. All right, so for this one, we're going to create some superheroes. It's pretty simple. There's a couple of different parts of the decorator pattern. The first is the object or the generic, whatever you want to call it, superhero object class that creates the superheroes. And then, so that's the first thing I'm going to set up. Then I'm going to create some individual superheroes using that object. And then lastly is we're going to decorate the individual superheroes. All right. And then we'll test it at the end per usual. All right, so creating the superhero object. Again, I'm going to be using functional-based objects. You can use class-based objects if you'd like. So superhero is going to be the name of my object. And we're going to pass in a name so that we can give each superhero their individual name. So then this dot name is equal to name. That's literally all you have to do to set up that superhero object. Checking comments, sorry. Okay, create some, oh, right. Okay, so then let's see, we're gonna create Wonder Woman. Do a new superhero, and her name is gonna be Wonder Woman. And then we're going to create another one, which will be Captain Marvel, new superhero, Marvel, and then last, let's just create 3. Superman, of course, new superhero, and the name will be Summerman. Superman. All right. And then now we're going to decorate those. So each, as you might expect with superheroes, each of them are going to have their own individual superpowers, right? So we could use this this object, this general superhero object, the super class interface. There's a bunch of different words for it to give them mutual things. Like, let's say this dot is super is true. So they're all going to be super, right? And they have individual names, but then we can add their own methods, and it's super easy. All you have to do is say like, wait, those aren't objects. I'm just gonna casing on that real quick. So Wonder Woman, and we're gonna say Wonder Woman has a whip attack, and that is gonna equal a function. And whenever she does her whip attack, we're gonna console log this dot name plus is doing a whip attack. So you can see all I'm doing right here is I'm just decorating this Wonder Woman object. So we know she'll have this attribute of name, and we know she'll have the attribute of this is super, but we'll also decorate her with a whip attack because that's her individual attack. So we can do the same thing with Captain Marvel and Superman. And so Captain Marvel dot, geez, I don't even know, travel through time. Function, console log, this dot name is traveling through time. And then lastly, Superman dot fly and console log this dot name plus is traveling through time. So it's that simple. There we go. We've decorated each of those individual objects. And then, so now let's go ahead and test them. So let's go ahead and console log, or wait, we can just call their method. So Wonder Woman dot whip attack. Captain Marvel, there you go. You see it in the console already. Captain Marvel dot travel through time, and Superman dot fly. All right, there it is. Wonder Woman is doing a whip attack. Captain Marvel is traveling through time. And I wrote traveling through time here as well. It's early. Like I said, is flying. There we go. All right, so right here. There you go. There is our structural design pattern of the decorator pattern. And next up, checking comments. No questions on that. If you have any questions, feel free to let me know. All right, next up is the behavioral command design pattern. So this design pattern is actually one of my personal favorites because if you, I mean, we're all developers, I'd assume. So if you've ever tried to create something like a calculator, which is what we're going to do, you know, it can get a little messy creating all of these functions. So I love this one because it encapsulates the object and allows each of those methods to be parameterized using different requests, and then queues the logging of those requests. That's super wordy. Feel free to reread that and soak that in on your own time. Let me show you what it does. That's the best way to explain this definition. So I'm going to come over here. Let me comment out those so we're not getting these console logging over and over again. So there's pretty much two parts to this. So the first is we're going to create our methods object. Excuse me. Hold on. Sorry about that. We're going to create our method object, and then we're going to create our calculator that calls methods by passing in. So this is a calculator object, just to clarify, passing in the parameters. All right. And then, per usual, we will test it at the end. All right, so the first thing we're going to do is we're going to create our calculator methods. So we're going to create the 4 basics. We're going to do the add method, which will be a function, and it's going to take in 2 numbers, an x and a y, and then we'll return x plus y. Don't like me doing this on the same line, so let's go ahead and get there. Subtract. This should be pretty obvious. Just run through this really fast. Turn x minus y. Multiply y. Return x times y, and divide. It's going to be a function as well. Return x divided by y. So that's all that we need for our calculator methods object. And then next, we're going to create our calculator object, which actually executes each of those methods by passing in the necessary parameters. So const calculator. Actually, I'm not going to call these as a new because I'm not using this method or this feature. So those are just going to be lowercase. So this is going to have an execute, and it's going to take in 3 different parameters. So later what we're going to be doing is we're just going to be calling our calculator with the execute method and the 3 parameters. So the first one is going to be the method. So add, subtract, multiply, and divide. And then num1, which will be that x and y, and num2, so x and y. So the first thing we're going to do is we're going to check to see if that method actually exists in our available methods, or if it doesn't, and then we'll return null if it doesn't. So if the method does not, not method in calculator methods, return. So if the method doesn't exist in our calculator methods. Otherwise, we will go ahead and return the calculator methods at the method that we've passed in. And we're going to pass that num1 and num2. So there you go. So if you look, we will be grabbing, if we pass an add, this will result in this method here, the add method. And then we're also passing a num1 and num2, which up here become x and y. I'm going to check for questions. No questions yet. OK. Now let's test it. That's it. That's all we have to do. So this is, we just use this execute command, and it sets it up super simple. So we just call our console log. Let's do a console log on each of these commands and say calculator.execute, and we're going to add 2, and we're going to add 5. So that should be 7, and we're getting 7 immediately there. Let's go ahead and I'm just going to copy this, and we're going to do that 4 times. Oh, wait, did I call it minus? No, subtract. Subtract, multiply, and divide. All right, so let me clear this out real quick just to make sure. Looks like there's some sort of error in there. Keep it. No, multiply. Oh, I forgot the L. Multiply. There you go. So you can see 7 is the addition method, minus 3 is the subtract, 10 is the multiply, and 0.4 is the divide. Awesome. So that is the command behavioral design pattern. Again, like I said, it makes it super easy. You can just set whatever the return value is to however you're going to use it. And all of that is managed in a completely separated out method, calculator methods object that is then called in the calculator object. All right. So next up, let me go over to my slides. This is such a fun one. It's simple, it's easy, it's the Singleton design pattern. It's another creational design pattern, and as the name suggests, it ensures that the class has only one instance, and we provide a global point of access to it. So this one's fairly easy to grasp the concept of. Let me comment out the okay. So today for this, I'm going to be building a single database instance. And it's fairly simple. We have literally just one part of this. So that is our Singleton object database. We're going to create that first, and then we're going to test it and make sure that we're only getting the single object. Okay, let me scroll. So we're going to set up our database. And unlike the other ones that I've set up before, this is actually going to be a self-invoking function. And we're going to do that in order to, wait, did I do that right? No. Okay, outside of that. So a self-invoking function, and what that's going to allow us to do is have some private methods as well as return the public methods. Let me show you what I mean. So the first, as I said, this is only a single instance of an object. So once this database instance has been set up, we want to make sure it doesn't create another one. So in order to do that, we need to set up this initial instance variable. And it's a let because we're going to reset it once. As you can see, we're going to check that it exists or not, based off of this being an empty variable or an undefined variable. And then we're going to have two private methods. So the first method is going to be the create instance method, which will handle the creation of it. And then the next method will be the get instance. And so that get instance is what we're actually going to return. So we're going to return and then a method called get, and that is going to return the method get instance, so that this publicly can be called as database.get. So we're going to set up this get instance first, and you'll see why in just a second. So if there is not an instance, right, what we're going to do is we're going to set instance to create, instance equals create instance. Otherwise, we're going to return the instance. So since we're setting this as setting this create instance function, that means we're going to need to return an object. I'm going to set up that object outside of here just so we have, so database object is equal to a function. And we're going to say this dot name is equal to my database. And just to show you that whenever I try to create more than one instance, I'm going to go ahead and create an ID, and that will be a random number. So I'm going to go ahead and do math.floor, math.random. I think it's like that, and 1000. Yeah, okay. Times 1000. There we go. So hopefully, whenever we return a new database object, if everything went well and my Singleton instance right here, right? If the instance doesn't exist, we create one. Otherwise, we return the instance that we've already created. So if everything went well, whenever I test this right now, it should work out. So let's go ahead and set up const db1 is equal to database.get. And then const db2 is equal to database.get as well. So this will ensure that these, whenever I console log db1 and db2, let's see what we get over here. You can see that the ID is the same. So if I save this, just so you can see that randomly generated number is the same. Change, force it to reload. That randomly generated number here on my database object is the same. And we can even double verify that by saying console log db1 triple equals db2. And that should console log true. There you go. So this is great, like if you have settings and you're using a cache key on those settings to make sure that the cache key is getting updated or that the cache is clearing whenever that ID changes. Awesome. Let me check, see if we have any questions. what was the previous pattern called? The previous pattern that I worked on was the command design pattern. That's the one I built the calculator out of. All right, so that was the Singleton design pattern. Where are we at on time? We have 15 minutes, about 15 minutes left. So if you have any questions about where I'm at, I want to pause real quick before I get into the facade design pattern and allow some time for questions. I'm going to keep going, but I'll keep an eye on the questions down there. So the facade design pattern is actually one that it's probably the one that I personally have seen the most in the professional code that I've worked on, because it separates your code out into a really, like if you've ever used like a utility tool where you move methods into a utility file and call that and import it into others, or maybe you have a utility package that's internally managed by your company. That is an example of the facade design pattern. So the definition here, right, is you attach additional responsibilities to an object, dynamically keeping the interface the same. Decorators provide flexible alternative to subclassing for extending functionality. This looks like I copied and pasted from my decorator pattern. It is. That is the wrong definition. I apologize. Let me dev.to. Let me pull up my design patterns. And just, I want to get you the actual definition. So it's provide a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use. So as I said, it's something like the utilities. So let's go ahead and create that. We're going to create just the get method just to show you. But this is where I'm going to be using that Axios library. If you're not familiar with Axios, it's just another way of fetching API data. So let's go ahead, and we're going to have a couple of different methods. So I'm actually going to create, just to show you, an entirely new file here. Okay, yeah, this is going to be too complicated and take too much time. So I'm just going to keep it all in one file. But generally, you'd have all of the methods in the facade separated out into a separate file, like I mentioned, like a utilities file, or separated into a node, an NPM package. So I'm just going to put a little wrapper around my facade here, just so you know what I would end up having in a separate file. Okay, so the first thing is going to be, we're going to create a couple of functions that we want managed here. So function get users, and that is just going to call this is not in the facade. The facade is an object, facade, and that is going to have just a method called get. So caps lock function, and we're going to pass in the URL and the params. And this is where I'm going to use Axios, which I've already imported way at the top up here. Let me go ahead. Where am I? Database object. Let me comment out that so we don't keep seeing that in the console. Okay, so this is where I'm going to use Axios and just do, if you're not too familiar with Axios, this is a quick overview, but we're going to go ahead and return Axios with the URL, the params, and the method will be the get method. And then after we do that, then we're going to do a conversion of the response, res.data, which is what Axios returns. Okay, so externally, we are going to, this is our facade right here. So in our file where we want to call the facade, for example, we could say function get users. And that's just going to call the general facade.get. And I've set up this little URL from JSON placeholder to just get the users. So JSON this, you can check that out. We'll see in just a second what that is. Oh, what's going on with my params? And then function get users by ID, and we're going to pass it, or get user by ID. And then we're going to also use that facade. Let me copy that URL again. And then this time, we're actually going to pass in an ID object. Return is not a method. OK, there you go. So now you can see we're using the facade to create this get method. And the great thing about that is later, if we ever decided to switch up our get method, all we have to do is update it here. Instead of calling this Axios in each one of these individually, this is just one time you set up the Axios get facade. And you could do post, patch, put, delete, all of the other methods as well. And you could even create a utility if you wanted, like a general one is something like adding the $sign, converting a number to a currency, floating out 2 digits and adding the $sign, a currency string would be another example of like a utility that would be in the facade file or library. And then let's test this. So because we are actually making an API request, we want to make sure we're waiting for the response. So I'm going to go ahead and create an async test function. Let's go ahead and grab those users. So const users equals get users. But I want this to be in a wait so we don't run the stuff below it. And then console log users. Let's make sure we're working over here. And I have to call that test function. Lastly, there we go. You can see, why is it console logging twice? We have 9 users that are getting returned here in that console log. Then let's go ahead and, we know that we have 10 users, but generally we wouldn't do it this way, is equal to await. We'd loop through all of the users, right? But I'm just going to go ahead and do get users get user by ID and number 1, and console log user 1. And there it is at the bottom. I'm not sure why this is running twice. That's confusing me, but that's okay. So here's user 1. There you go. We have only about 5 minutes. The strategy design pattern, I will just show you my code for that instead of building it from scratch. So here, if you look on my GitHub, so this is where you define a family of algorithms. This is pretty wordy, so I apologize. Encapsulate each one and then make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. So whenever I originally created this, I decided, because I work at Fandango, to create a movie ticketing strategy. So right here, we set up the Regal object that has the get ticket price. And that takes in a quantity. And then it returns the quantity times $11.99. Same thing with AMC, just $10.99. And Cinemark, which is $9.99. And then what we do is we create this ticket price object. I might actually rename this if I was rewriting it right here to theater. So function ticket price, and that has a theater chain, which we don't set immediately, and we don't even pass in as a parameter. We actually set it with the set theater chain method. And then this ticket price also has a calculate. So that takes the theater chain, and then it returns the get ticket price. So depending on whatever we set as the theater chain, like right here, const Regal, AMC, Cinemark, we've set up there. And then we created our ticket price object as well. And then we set the theater as Regal, and then we calculate that times 2. Same thing with AMC, and calculate that. And what that's going to do is that's going to attach. You see I'm updating without creating a new ticket price. I'm updating the theater chain and then just calculating that. All right, so that is the strategy design pattern. Sorry, I sort of ran out of time on that one. But those are the 6 awesome JavaScript design patterns that I wanted to show you today. If you have any questions or any of this does not make sense, feel free to hit me up on Twitter @contemporary. And you can even check out all of these on my GitHub in my JavaScript design patterns repo. I will be saving all of the code that I wrote today in one big block onto my GitHub as well, into this. And I will save it in a folder that's probably called something like JavaScript Marathon and the date. So check that out. If it's not there in a couple of hours, check back tomorrow. I'm going to pause for the next 2 minutes, or not 2 minutes, but a couple of seconds, and see if there's any questions. If not, that is time for me. We're at an hour. Again, want to be respectful of your time. Thank you so much for joining me. Thank you, this.labs, for having me, Tara for hosting, and Tracy for inviting me. Follow me on Twitter, and I hope to see you guys soon. Thanks so much.